Welcome to Ask and Learn.
Okay, so for this problem, we have a pump which has a length of 0.25 meters, and so suppose this is the pump, and then we have a piston over here. So this is the piston, and then we add some pressure here. So we want to pump this the air inside this pump from initial pressure is 1 atmosphere to 3.8 times 10 to the 5th Pascal. So let's see how far down the length of the cylinder has to move. Okay, so for part A, suppose the length of this pump is L, okay, and suppose that the cross section of this pump, like this area equal to S. Then we have and this is also adiabatic process. So we have P times V gamma is constant. Okay. And the V here just simply equal to L times S. So we have P initial times S times L initial with power gamma equal to P final times S times L final with power gamma. All right. And we already know PI and the PF, that is the initial pressure and the final pressure. And the S is just a constant, and we're going to cross out S on both sides. And Li is the initial length, which is 0.25 meters, and Lf is the unknown variable. So we can solve for this Lf. Lf equal to Li times Pi over Pf with power 1 over gamma. For air, gamma equal to 1.4. Okay, so we can plug in the numbers, and the solution is 0.97 meters, 0.097 meters. And because we want to find out how far down the length cylinder has to move, so delta L equal to Li minus Lf, which equal to 0.153 meters. Okay. And for part B, so we know the initial temperature, and we want to find out the final temperature. We already have this formula. This is a constant, and by applying the other one, PV equal to RT, you will obtain this formula. The T gamma over P gamma minus 1 is a constant. Okay, so we have T final equal to T initial times P final over P initial with power gamma minus 1 over gamma. So you just plug in the numbers. Ti is 27 Celsius degrees, but here you need to transfer the Celsius degrees in Kelvin degrees. So 27 Celsius degrees equal to 300 Kelvin. Okay. So initial temperature is 300 Kelvin, and PF is this one is 3.8 times 10 to the 5th, and PI is 1.01 times 10 to the 5th, and gamma is 1.4. So we obtain the final the solution is 4, 3, 8 Kelvin. And it is also equal to 165 Celsius degrees. All right. And part C, we want to find out the work that added to the gas. Okay. So because this is an adiabatic process, so the work formula for work is simply equal to the change in internal energy, which is N times CV times delta T. Here, delta T is TF minus TI. So TF is this 165 Celsius degrees, and TI is 27 degrees. N is 20 moles, and the CV is given to be 20.8. So plug in the numbers, and the final solution is 57, let me see, 408 joules. I remember that this work is actually done by the gas, done into the gas. Yeah. So, yeah, that's it.